What are ultra-pure chemicals and what are the application areas? We'll look into this now. Electronic product, semiconductor device require good product consistency and highest level of purity. Semiconductor is all about precision manufacturing, zero error, and getting everything down to the atomic level. In the fabrication process of electronic semiconductor devices, several materials have to be cleaned and etched. The ultra-pure chemicals, such as acids, bases, ammonium fluoride, hydrogen peroxide, and several others, are used as cleansers and etchants in semiconductor and microprocess manufacturing. Now, having looked into what are ultra-pure chemicals and application areas, let us look into the classification of ultra-pure chemicals. Ultra-pure chemicals, which are essentially wet electronic chemicals, can be mainly divided into general chemicals and functional chemicals according to their uses and applications. General chemicals are mainly high purity solvents such as hydrogen peroxide, hydrofluoric acid, sulfuric acid, phosphoric acid, hydrochloric acid, nitric acid, etc. The functional chemicals refer to formulas that achieve special functions through compounding methods and meet special process requirements in manufacturing. Functional chemicals mainly include developing solutions, stripping solution, cleaning solution, etching solution, etc. Now, having looked into this, let us look into the global status of electronic and semiconductor industry. The semiconductor device market has continued to grow, driven by the demand for 5G smartphones and amid lifestyle changes. Increased demand for personal computers and data center related equipment, as well as analog integrated circuits such as signal conversion, automotive specific analog applications, and power management. More than 500 billion US dollar of investments have been announced for chip expansions and creation of capacity for chip production to be built over the next 5 years across the world in different countries. A strong growth cycle is expected to start in the year 2025 and carry the semiconductor electronic industry into the next decade. More than US $130 billion investment have been planned in the United States alone. China is now one of the largest semiconductor markets in the world and is continuing to grow. Now, having looked into the global scenario, let us look into the Indian scenario for semiconductor and electronic industry. In the year 2023, the Indian semiconductor industry was valued at US dollar 34.3 billion and is expected to reach as high as 100.2 US dollar billion by the year 2032, driven by an increasing demand for smartphones, wearables, automotive parts, and computers in India. Currently, India relies largely on import for semiconductors, mainly from Taiwan, China, Korea, and Vietnam. To reduce its dependence on import of semiconductors, the Ministry of Electronics and Information Technology of Government of India has launched the India Semiconductor Mission with a US dollar 10 billion commitment. This includes incentives for manufacturing and the design-linked incentive scheme to support semiconductor startups. With such strong support from the Government of India, the electronic and semiconductor industry is likely to reach steady growth in the coming years. Now, a number of chip projects have been announced Now let us look into the number of chip projects that have been announced in recent time. Number of chip projects have been announced in India recently, such as the following: chip project in Assam, Tata's chip project in Gujarat, Kane's chip project in Gujarat, Micron's chip project in Gujarat, Adani's proposed chip project in Maharashtra, proposal of Vedanta Group, silicon carbide fab unit in Odisha, and investment proposal for Government of India owned Semiconductor laboratory in Mohali in Punjab state. A few more projects have also been announced, which are in the preliminary planning stage. Now, this is very impressive. These kind of chip projects have been announced mainly because of the huge support given by the Government of India. With the development of the semiconductor and chip project in electronic industry, the demand for ultra-pure chemical in the country is likely to go up steadily in the coming years, not only in India, all over the world. Now, having looked into this, let us look into this global scenario for ultra-pure chemicals. See, ultra-pure chemicals market size in the world, which is around $4.2 billion in the year 2023, is likely to double to $8.4 billion into year 2032 across the world. That means the whole industry is going to double in capacity in the next few years. The growth rate in demand for ultra-pure chemicals, the global market, between the year 2024 and 2032 is likely to be around 8%, which is a very, very impressive growth rate by global standards. Now, what is the ultra-pure chemical market share by region? If we look into that, Europe and Americas hold as much as 35% of the market share for ultra-pure chemical production. Next comes Japan with around 28% of the market share. Taiwan, such a small country, holds around 10% of the market share in the world market. Again, South Korea, another small country by region, holds as much as 16% of the global market share for ultra-pure chemical production. China comes next with 9% for the global market share. Then there are other countries such as Malaysia who hold around 2% of the global market share. You will find I have not made any mention about India because India has no market share in the global market. Now, let us look into this global market share of ultra-pure chemicals, individual chemicals. There are a number of ultra-pure chemicals, which I already mentioned a little, of which sulfuric acid's market share in the ultra-pure chemicals is as much as 31.24%, with the projected growth rate in the next few years of as high as 4.93%. Next comes hydrogen peroxide with 28.68% with a growth rate of 4.5%. Ammonia has a market share of 8.11% with a growth rate of 5.96% projected. Then hydrofluoric acid, share of 5.51% with a growth rate of as high as 11.7%. Then nitric acid with a market share of 3.9% with a growth rate projected of 5.61%. Then isopropyl alcohol with a market share of 2.68% with a projected share growth of 3.8%. Then phosphoric acid with a global market share of 0.69% with projected growth rate of 5.9%. Then hydrochloric acid with a global market share of 0.58% with a projected growth of 6.1%. Apart from these ultra-pure chemicals, others which are called as functional chemicals that include etching solution, stripping solution, and buffer etching solution hold global market share of 18.61% with a projected annual growth rate of 5.6%. These are all very, very impressive figures. And all these ultra-pure chemicals you would know are likely to have a steady growth in demand in the global market in the coming years. Now, let us look into this selected producers of ultra-pure chemicals in the global market. There are reported to be around 140 producers of ultra-pure chemicals in the world. A number of expansion proposals and new projects are under planning for implementation in different countries. Ultrapure chemical projects are located in several countries such as USA, Japan, South Korea, Vietnam, China, and others. Unfortunately, none of the projects are presently operating in India or being planned in India so far. Now let us look into this, some of the names of the major producers and their installed capacity level. Just to give you an idea, what is the type of capacity that are being implemented or that have been implemented and that are being planned. Mitsubishi Gas Chemical, who have planned location at Yamakita in Japan, Saga in Japan, Tokachi in Japan, and China, produces hydrogen peroxide ranging in capacity from 12,000 ton per annum to 90,000 ton per annum in different locations. Then NGC Pure Chemical America, which has plant in USA, Singapore, and Taiwan, has capacities in the range of 30,000 ton to 140,000 ton for hydrogen peroxide. Then there is another company, LSNMM, incorporated in South Korea, who produces sulfuric acid high purity of capacity as a 180,000 ton per annum. Then we got OCA company in South Korea, who has a capacity of 85,000 tons for hydrogen peroxide per annum and 26,000 tons for phosphoric acid per annum. Then you got Zhejiang Morita New Materials Company in China, who have hydrofluoric acid of capacity 50,000 tons per annum and ammonium hydroxide of capacity 15,000 tons per annum. Then there's a Formosa Tokuyama company in Taiwan, who had isopropyl capacity of 30,000 tons per annum. Then we have Grand IT in China, who produces nitric acid of capacity 30,000 tons per annum. I'm just giving you an idea of the type of capacities. Most of the capacities you find are in the range of 30,000 ton to 1 lakh ton per annum. This is the kind of capacities that have been implemented, that have been planned so far. Now let us look at the specification of this product. Now, we have taken one case study of ultrapure ammonium hydroxide. Just give you an idea. See, heavy metal concentrations in the ultrapure chemical are extremely low, measured in parts per billion or parts per trillion. Very, very high, low level of that is only permitted, organic and metallic impurities. Now, I'm just giving a specification of one product to give you an idea as to what extent of the specification are being tightly implemented and tightly analyzed. Look at these figures. Some of these things are in the region of maximum of 0.01 ppm. There are some in the case of 0.05 ppm and so on. I've given so many specifications for each one. Similarly, for every one of the ultrapure chemicals, the specifications are analyzed individually for each one of the impurities, and they are provided by the producers. Having looked into this, let us look into what is the process that is being adopted for ultrapure chemical. See here, what happens is most of the international producers who produce ultrapure chemicals start from the basic stage. For example, the case of ultrapure sulfuric acid, they start from the sulfuric acid, sulfur, produce a technical grade sulfuric acid, and then purify the ultrapure sulfuric acid level. I have not come across any instance of people buying technical grade sulfuric acid and producing ultrapure chemical sulfuric acid. This, I think, is very essential from the point of view of the economic size and rate of return from the particular project. Now, what are the type of process that is being employed for purifying the technical grade? Advanced cleaning methods like distillation, sublimation, and filtration are used in the production process to reach the required level of purity in ultrapure chemicals, which is often parts per billion or even parts per trillion for metals and organic impurities. Several types of processes are employed depending upon the particular ultrapure chemicals. Such processes include positive pressure distillation, negative pressure distillation, sub-boiling distillation, batch distillation, isothermal diffusion, sub-boiling distillation. We have just given only a few examples to give an idea of what kind of unit operations and processes that are being used. Now, having given this, a broad picture of this, what is our recommendation? Since the global production of semiconductor electronic chemicals are also steadily increasing, and India is also taking steps to boost the production of semiconductor electronic products, Indian import and export market for ultra-pure chemicals is an attractive option for investment. Not only India, this is so for all the other countries in the world because ultra-pure chemicals are globally produced products and globally used as a product, with likely international trade becoming having a really playing a very big role in the ultra-pure chemical marketing in the coming years. Since number of industrial chemicals are produced in India and several other countries, which can be purified to ultra-purity level to meet the requirement of rapidly expanding electronic and semiconductor industry, both in India and abroad, it is hoped that the project promoters would be enthused to produce ultra-pure chemicals meeting the requirement of electronic and semiconductor industry. Now, having looked into this, now the Nandini Consultancy Center has released recently a report on introductory report. A few details on this are given here now. Nandini Consultancy Center, a chemical engineering and chemical business consulting organization based in Chennai, has now released an introductory report on investment opportunity in ultra-pure chemicals used in electronic and semiconductor industry. This introductory report on ultra-pure chemicals for use in electronic and semiconductor industry has been prepared with the objective of providing broad understanding on the demand and technology aspects of ultra-pure chemicals. This introductory report consists of around 340 pages. Ultra-pure chemicals covered in the report are phosphoric acid, sulfuric acid, nitric acid, hydrochloric acid, hydrofluoric acid, hydrogen peroxide, isopropyl alcohol, ammonium hydroxide, phosphorus oxychloride, and of course, ultra-pure water, which is very, very important, ultra-pure water for the production of various ultra-pure chemicals. For more details on this introductory report, kindly contact Nandini Consulting Center, and the email address is given in the report here. Thank you very much.